Pythagoras theorem actually talks about right triangles. Okay, now the rule is this. If I have a triangle that looks like this, notice that I have this little 90-degree angle here, right? That means if I have the side, the angles A, B, C, then the sides are given by C, A, and B. Okay? And Pythagoras' rule says that the longest side squared, that's C squared, so that's this thing right here. So that's this thing right here, is equal to A squared plus B squared. So, for example, there are two types of questions that you can have. I'm going to show you what those two types are. Okay? The two types of equations look like this. Let me just move this up a little bit. So here is type 1. You have two sides. You have two legs of the triangle. So let's say that this is 3 and this is 4. And we have a right corner here. And we need this value here. Let's call it x. Okay? Based on this triangle, based on what we have up here, this squared plus this squared is going to equal this squared. So we start by writing out our equation. C squared equals A squared plus B squared. Now we do our substitution. X is C squared, so we say x squared is equal to, and then we write 3 squared plus 4 squared. We calculate that. 3 times 3 plus 4 times 4 is equal to 9 plus 16, which is equal to 25. So that means our x squareds is equal to 25. And this is why we did our square root a while back. Okay. So this is why we basically did that square rooting thing a while back, because we need to say the very last step is equal to x is equal to the square root of 25. Punch that in your calculator. That means x is equal to 5. That is type 1. Okay? Take a moment, copy that down. And for type 1, you literally have both legs. Now, for type 2, we have a slightly different configuration to do the calculation. In this case, we're going to have one leg and one hypotenuse. So, for example, imagine if we had something like this. We knew the hypotenuse, but we knew one side. So we had something like this, or you had something that looked like this. 4 was here, and our missing side was on the other leg of our triangle. Okay? In this case, we're going to label the missing side x again. And now that we've labeled our side x again, this is how we calculate x. Now, to remember the original equation for the Pythagoras theorem was c squared equals a squared plus b squared. Now, what we're going to do is we're going to rewrite the equation so it's in terms of one of the legs that are missing. So in this case, I'm going to call this a squared equals c squared minus b squared. So that is the form that we will use. We will use a squared equals c squared minus b squared if we are looking for one of the legs, okay? And all we're going to do is substitute what we know, okay? Based on the fact that we have this right angled triangle, c is 5, minus b, which is 4, and a is our x squared term. Now, all we have to do is figure out what 5 squared minus 4 squared is. So we got 25 minus 16, which gives us 9. So that means we just copy down this x squared term right to the end. And then finally, to get rid of this squared term, all we're going to do is we're going to say x is equal to the square root of 9. And the square root of 9 gives us a final answer. X is equal to 3. And we're done. So, just a quick recap. When we have both legs, we use c squared equals a squared plus b squared. When we have one leg missing, we say a squared equals c squared minus b squared and solve accordingly to find the missing side. Okay? And that's it. All right. Get to work.